Assalamu alaikum everyone. Today we are going to discuss about a new topic which is a Le-Chatelier's principle. A French chemist named as Le-Chatelier uh, gave the idea of Le-Chatelier's principle that usually whenever we see in industries there is more requirement of a certain product or more requirement of a certain reactant, or sometimes we need to save our time as well as our um, sources resources in order to make the desirable product or desirable reactant. So in this case, Le Chatelier came to solve this problem by within the equilibrium, such that whenever a reaction is occurring, there is requirement of an equilibrium. The requirement of equilibrium is established. But now, in order to look at the equilibrium, whether if we want, suppose if we are having the Haber's process in which synthesis of ammonia occurs, if we want more product, then in that case a more product requires to not have the equilibrium, because at equilibrium rate of forward and backward reaction occurring are same, which means both reactant and product concentration is equal, due to which no synthesis of ammonia is possible at the moment, right? At the moment, in that case we need to more, if we are supposed to make more ammonia, then we need to make more of the products and cause the reaction to go in the forward direction. So in that case, Le Chatelier came out with certain factors that whenever if there is an external factor acting upon equilibrium, it causes a stress or strain over the equilibrium. Le Chatelier principle said that he basically studied the effects of factors on equilibrium in the presence of stress and strain. So there are basically um three types of factors present in our book. We are just going to discuss those as well. First includes the concentration of reactants and products, second pressure, and third the temperature. Presence of catalyst is also there, but catalysts do not affect the rate of does not affect the equilibrium, even though they increase the rate of forward and backward reaction both. But as a result of gradual increase in both forward and backward reaction, which is equal, it causes to have no impact over the Kc value. Likewise, if we are here to discuss about concentration of reactants and products, let us discuss first. Let us suppose we have an equation. We have a reaction between three hydrogen plus hydrogen, and here we are having the equilibrium sign. Um, Equilibrium sign is there, and here we have our product ammonia. This is Haber's process. We are going to have a separate video for that as well, so this is only for explanation. uh, all right, so this is the sign of equilibrium, and here as you can see that if we are increasing the concentration of reactants, let's suppose if we are this condition is at equilibrium, so if we are decreasing or increasing the concentration, let us suppose we are increasing the concentration of reactants. So increasing the concentration of reactant, let's suppose increasing the concentration of hydrogen will cause to have more concentration of reactants. As there will be more concentration of reactants, there will be more number of effective collisions per second of the reactant. As there will be more number of effective collisions per second of the reactant, it will cause to increase the rate of forward reaction, as a result of which, as there will be an increase in rate of forward reaction, it will cause to produce more of the product, which is ammonia. So in this case, when the equilibrium is disturbed, the reaction which would be occurring would be a forward reaction. Net reaction would be occurring would be a forward reaction. Now once more of the product is formed, product concentration is increased. As product concentration is increased, this increase in product concentration will cause many of the products to have more number of effective collisions per second among them, as a result of which the rate of backward reaction will now increase. As the rate of backward reaction will now increase due to more concentration of product, it will cause due to more number of effective collisions per second, it will cause the ammonia which is present over here to convert back into the reactant, increasing the rate of backward reaction. So in this case, uh, again the rate of backward reaction will be increased. But when the equilibrium was disturbed, the net forward net reaction which was occurring over here was a forward reaction. So we will consider that disturbing the change produce forward reaction. Now further, when backward reaction occurs, the reaction tends to maintain its equilibrium once again. Of course that requires some time, and before this condition prevails, the forward reaction occurs. So when backward reaction occurs, it again causes to form more of the reactants, and there comes a time when again the forward and backward reactions become equal. So in this case, as of forward and backward reaction become equal, it causes to establish the equilibrium. Now, in this case, following the same phenomena, if we are decreasing the concentration of reactants, it will cause the concentration of products to be increased, reactants to be decreased, more number of effective collisions of products, and causing more amount of products to collide with each other and go for the backward reaction. Likewise, if we are increasing the concentration of products, same goes with increasing the concentration of products, it will cause more concentration of products, more number of effective collisions per second, as a result of which more of the products will be able to participate in the backward reaction, which means net reaction, the rate of backward reaction will be higher than forward reaction, and backward reaction will be occurring. Likewise, if we talk about the decrease in the concentration of products, concentration products of products is decreased, then it will cause the uh, increase in concentration of reactants, which means maximum number of collisions of reactants will be occur, and maximum number of collisions of reactants maximum number of collisions of reactants or maximum number of collisions of reactants will cause more of the forward reaction, rate of forward reaction will occur, will increase, and thus produce more products. So in this case, this is how we consider the phenomena of concentration of reactants and products. Likewise, if we talk about temperature, now on the basis of temperature there are two types of reactions, which is the exothermic reaction, exothermic equilibrium, and second type of equilibrium is the endothermic equilibrium. Now coming to first and foremost exothermic equilibrium, let's suppose if we have an exothermic reaction, the same reaction which we are having over here, this is exothermic reaction, right? And all right, so this is the exothermic reaction. All right, as it is the exothermic reaction, uh, because what is the significance, what is the sign of exothermic reaction? Exothermic reaction is first and foremost determined by a minus sign, which minus sign shows that here it is basically evolving heat, there's evolution of heat. So whenever there's exothermic reaction minus sign, then we say that the heat can be mentioned within the reaction according to thermodynamics on the product side or on the right hand side. Likewise, if we come to an endothermic reaction will be having a minus sign, will be having a not a minus sign but a pillar sign, because here heat is being absorbed by the reactants, as a result of which it will cause to write the heat as a reactant. It will cause to write heat on the reactant side or on the left hand side. Hydrogen and iodine, this is again another example, this is again an example of endothermic reaction, heat, right? So here we have our endothermic reaction. So going on here, the product which is formed is hydrogen iodide, hydrogen I hydrogen iodide. Now in this case, heat is written on the left hand side. Now for let's suppose, oops, all right, you might understand what the problem is. So now here, as in an exothermic reaction, if we increase the amount of heat, if we increase the heat, then increasing the heat in an exothermic reaction will cause to form an endothermic reaction. It will cause the more of the products which is ammonia to absorb the amount of heat, due to which the heat on the product side will be increased. And this is what the Le-Chatelier principle says. Le-Chatelier principle says that whenever there's a disturbance in the equilibrium, the species which are participating in the equilibrium tend to regulate that disturbance. Now, in order to regulate that disturbance, the ammonia molecules having more amount of heat on their side will tend to form more of the reactants by forming the backward reaction, as a result of which As the ammonia molecules will tend to undergo backward reaction, they will utilize the amount of heat and thus reduce the amount of heat back to normal exothermic reaction heat. As a result of which, the equilibrium will be again achieved, and before the achievement of equilibrium, the disturbance will lead to a backward reaction, which means equilibrium will be achieved, but there will be more formation of reactants. Kc value will remain constant, but there will be more uh, Kc value will remain constant, but there will be more formation of reactants. Likewise, if we want to gain more products, if we want more amount of products, then this will require more amount of it will require less amount of heat, which means if you're decreasing the heat, then in order to evolve more of the heat, the system will tend to undergo a forward reaction to evolve more amount of heat by causing the reactants will tend to collide with each other, increase their rate of reaction, increase the rate of forward reaction, collide more with each other, increase the number of effective collisions, increase the forward reaction rate, and thus ultimately go for making uh, the ammonia molecules and evolving much amount of heat back to normal exothermic reactions heat. As a result of which, again, this will lead to establishment of the equilibrium, but that establishment will lead to a forward reaction, and that forward reaction will cause to give us more products. Likewise, if we talk about other phenomena over here, about endothermic reaction, if we are supposed to talk about endothermic reaction, if the amount of heat is over in the endothermic reaction is increased, amount of heat in endothermic reaction is increased, it will cause more of the reactants to absorb the high amount of heat of reaction. As a result of which, mm, in order to stabilize the system, the reactants will tend to absorb the amount of heat and go in the forward direction in order to form the equilibrium stage. But before achieving that, there will be more formation of products because there will be a high amount of uh, rate of forward reaction occurring. Likewise, if we talk about decreasing the amount of heat will cause more of the products to come in the on the reactant side in order to regulate the system's heat. So in order to regulate the system's heat, more amount of products will be decomposed into the reactants by undergoing backward reaction in order to establish the equilibrium condition, as a result of which backward reaction will occur. As a result of backward reaction occurring, it will cause as a result of backward reaction occurring, the backward reaction will lead to more formation of reactants. So in this case, if endothermic reaction requires more products, increase the amount of heat. If exothermic reaction requires more products, decrease the amount of heat. This is a principle. After that, coming to the rate of change of pressure, if we are increasing or decreasing the pressure, let's suppose we have the same equation over here. uh, this is the same equation. One more thing, rate the change in pressure or change in volume is only applicable for those reactions in which there is reversible gases, in which there are reversible gases present, which means gases should be involved in the reaction, as well as the number of moles of reactants and products should be same, which means number of moles of reactants and products should not be same, sorry. So the conditions for pressure, effect of pressure on the equilibrium is such that there should be gases. Of course, equilibrium is there, so reversible reaction will be occurring. And one more thing, that here there should be unequal concentration of reactants and products, 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 such that this unequal concentration of reactants and products will lead to affect the change in pressure or volume over the equilibrium. And there should be a unit of kc for effect of pressure. There should be a unit of kc. The same thing is same, that if we have a unit, which means there is unequal concentration on reactant and product side. Let us suppose the same equation over here. Let's get the Haber's process. Let me just place it over here. All right, so let's suppose this is the reaction on this hand side. uh, so here, within this reaction, we have more concentration of we have more concentration of volume, we have, more concentration of reactants as compared to concentration of products. So we can say that according to Henry's law, at constant temperature and pressure, the volume of a gas is directly proportional to the concentration of moles of the gas in a chemical reaction. So in that case, as the concentration is more on reactant side, we can consider this concentration of 4 moles, because there are 3 moles of hydrogen, 1 mole of nitrogen. Concentration can be regarded as the volume according to Henry's law, as a result of which we can say that here the volume is 4V, and on the reactant side we can say that the volume is 2V, because of less concentration. And now here there's more volume on the reactant side, less volume on the product side. Now, if we are having, let's suppose if we are increasing the volume in the equilibrium mixture, if we are increasing the volume on the equilibrium mixture, the increase in volume on the equilibrium mixture, increase in the volume of mixture will cause to, you know increase, if you're increasing the equilibrium mixtures volume, then increase in the equilibrium mixtures volume will cause to decrease the pressure. So here, as you can see, if the volume is increased over here, then the pressure is decreased, which means this side, reactant side, is having less pressure. uh, it is having less pressure. Pressure is less. On the other hand side, this is having more less volume, so it is having more pressure. Now, in this case, if there is less pressure on the reactant side, more pressure on the product side, in order to uh, stabilize, in order to you know affect the equilibrium, if there is, for suppose, increase in the concentration of pressure, if there's increase in the concentration of pressure, then we will be, if causing the system to minimize its volume, reduce the volume, as a result of which, in order to reduce the volume, we need to conduct the reaction on the forward side, because on forward side, within the equilibrium mixture, there will be more concentration of, there will be more concentration of products, and products are already having less number of moles, due to which, if we are going for the forward side, if we are increasing the pressure, then we need to reduce the volume, and for reducing the volume we need to go on the product side. As we go on the product side, this will cause to conduct a forward reaction if we are increasing the pressure, or if we are uh, providing increased pressure, or if you are providing decreased volume. If you are decreasing the volume, then decrease in volume will cause to conduct the uh, forward reaction. Likewise, if we are decreasing the pressure, if we are decreasing the pressure, then contrarily we need to counteract, because this is what the Le-Chatelier's principles say, that we need to counteract. And as the pressure is being decreased, we need to increase the volume with regard to decrease in the pressure. Now, in order to increase the volume with regard to the pressure, we need to conduct a backward reaction, because backward reaction causes to form more of the reactants, and more of the reactants are having a more number of moles, which means more number of volumes concentration. As there is more volume on the reactant side, we can say that we should conduct a backward reaction, and at that moment the reaction which would be favored within these species would be a backward reaction. So in this case, this is how the concentration of products and reactants is affected. One more phenomena which can be applied over here is such that if there's high amount of volume on this side and there's less amount of volume on this side, then if we are increasing the volume, then if we are increasing the volume, then increase in volume will lead, if we are increasing the volume, if we are increasing the volume, we can directly solve it with reference to the volume, because here if we are increasing the volume within the equilibrium mixture, this is basically equilibrium mixture, and if we are increasing the volume, then this will cause to conduct, if we are increasing the volume, then it will cause to conduct a backward reaction, because if we increase the volume, the quantity with less a volume will be affected, because if we are, for suppose, if there is increase in the volume, if you are increasing the volume, then that will cause volume will tend to move from high concentration to lower concentration, due to which, as the volume will be increased, then 2 wall here 2 decimeter cube will be increased, for suppose, to 4, 5 decimeter cube, 5V. So at that case, this will cause to conduct a backward reaction, and once when we are decreasing the volume, the decrease in volume will lead to cause will lead to decrease the concentration of increased volume, as a result of which it will lead to the formation of a forward reaction in which more number of products will be formed. This is a reaction which we are supposed to discuss over here. One more thing, effect of catalysts do not play a vital role in affecting the Kc value, because they only tend to increase the number of effect, they only cause to lower the activation energy, due to which the rate of forward and backward reaction is increased. But since the rate of forward and backward reaction is increased at an equal stage, at an equalizer stage, there would be no effect on the value of Kc. And we might have studied in catalyst reaction kinetics that catalysts do not affect the equilibrium, even though if they are participating in the reaction. So this is all about this video. Hopefully we'll meet again in another one.